Hello everyone, welcome to Vinoth Rathinam tutorials. In this video, we are going to learn about inverse of a matrix. So in order to find the A inverse, we have to follow 5 steps. The first step is we have to verify the given matrix is non-singular. Non-singular means the determinant of the matrix is not equal to 0. And the second step is we have to calculate the matrix minus. From the matrix minus, the third step will be we have to form the cofactor matrix. Then fourth step we have to find the adjoint, and the last step is the value needs to be multiplied by 1 by determinant. The formula for A inverse is 1 by this is determinant of A into adjoint of A. In the previous video, in order to find the A inverse, we have completed what is its determinant value and calculate the matrix minus. In this video, we will see the remaining 3 steps. A short recap, this is the matrix and the determinant value is minus 40. So if it is not equal to 0, we call it as non-singular matrix. If a matrix is non-singular, then A inverse is possible. After calculating the matrix inverse, the next step will be we have to calculate the minus. In order to calculate the minus of a matrix, we have to calculate the minus of each value. For minus of each value, we have to ignore the values of the current rows and column. And then we have to write the remaining submatrix. For example, if it is 1, the submatrix will be after ignoring its column and row 0, minus 1, minus 3, 2. That is what written here. For each value, we have to calculate the minus, and finally we have to write the minus of the matrix. And the next step is after calculating the minus, we have to convert that particular matrix to a matrix of cofactor. Here the cofactor is represented by C of ij, that is I row j column, and C of ij equal to minus 1 power I plus j into m of ij. M of ij is nothing but minus of the matrix we already calculated. Now for each particular minus value, we are going to calculate the cofactor. Let's go step by step. Cofactor of first row first column, which is equal to minus 1, 1 plus 1 into m of first row first column, it is minus 3. So minus 3, which is equivalent to minus 3. Then C of 1, 2. C of first row second column into, and its value is 7 into 7. The final value will be minus 1 into 7, minus 7. Then first row third column 1 plus 3 into, its value is minus 9. Minus 9, which is equivalent to power 4. So it's a positive value. 1 into minus 9, minus 9. Then C of second row first column minus 1, 2 plus 1 into second row first column, the value is 11, which is equivalent to minus 11, because minus power 3 minus 1 into 11, it is minus 11. Then second row second column cofactor minus 1, 2 plus 2 into this value, it is 1, which is equivalent to 1. C of second row third column minus 1, 2 plus 3 into minus 7. So the value is plus 7. Then C of third row first column, so minus 1, 3 plus 1 into minus 4. Minus 4, which is equivalent to minus 4. Then C of 3, 2 equal to minus 1, 3 plus 2 into third row second column, the value is minus 4. So minus into minus 4, it is plus 4. Then the last row, last column, so minus 1, 3 plus 3 into minus 12. So the final value will be minus 12. We found the cofactor for each values. Now matrix of cofactors. A new matrix we found, so let me say it as a B. We have to write the value minus 3, minus 7, minus 9, minus 3, minus 7, minus 9, then minus 11, 1, 7, minus 11, 1, 7, then minus 4, 4, minus 12, minus 4, 4, minus 12. It's a 3 cross 3. So this is how we have to calculate the matrix of cofactor, and there is a simplest shortcut. We call it as checkerboard. Using checkerboard, we can easily cross verify. This is how sign will comes: plus, minus, plus, minus, plus, minus, plus, minus, plus. This is how the sign will be distributed. As per the checkerboard, these values, that is, this 4 value sign will be changed and the remaining value remains the same. If you cross verify, you can see 7, minus 7, minus 4, 11. Here you can see plus 7, 7, 4, minus 11. So the plus will change to minus, minus will change to plus, and the remaining value remains the same. Now the fourth step is we have to find the adjoint. The adjoint also called as adjunct. Adjoint is very easier. Adjoint means transpose of matrix. So we know the matrix B. For this we have to take the transpose. That's it. So it's going to be B transpose or adjoint of B. Transpose means converting all rows to column, or vice versa. We can change the columns to rows anyway. The first row will be this one. So minus 3, minus 11, minus 4, minus 3, minus 11, minus 4. Second row will be minus 7, 1, 4, minus 7, 1, 4, and third row will be minus 9, 7, minus 12, minus 9, 7, minus 12. 3 cross 3. Simple step. Finding the adjoint is very easy. After this, the fifth step is you have to multiply adjoint by 1 by determinant. It is nothing but the formula of A inverse. A inverse equal to 1 by determinant of A into adjoint of A, where A is not equal to 0. We have checked this. Now we know adjoint value, determinant value. Just substitute the value and find the final output. We know the determinant value 1 by minus 40 and write this particular value. Taking this minus 40 inside and divide each element, it's going to be like we have to take minus 40 inside. When you take minus 40, minus value change to plus and plus value will change to minus. And this is how we have to calculate the A inverse. It's a very lengthy process, but this is very important problem. In some examples, they would have divided 3 by 40 and mention it as a decimal number. So, hope you got a clear picture how to calculate the A inverse using 5 steps. That's the end of this video. Thanks for watching. Happy learning.